Welcome to The Deep Dive, the show engineered to deliver insights that really matter for your professional growth. Today, we're diving headfirst into a topic that's just buzzing around every engineering team: AI. It feels like we're constantly on the edge of some, huge overnight AI revolution, doesn't it? Always waiting for that fabled GPT-5 to swoop in and just change everything. But, okay, let's unpack this a little. Our sources reveal a reality that's maybe a bit more grounded. AI model improvements, yeah, they're significant, but they tend to be gradual, not these sudden exponential leaps we imagine. The real bottleneck, both for companies trying to boost efficiency and for engineers like you trying to get ahead. Well, it isn't just about waiting for a smarter model. It's much more about how we creatively leverage the powerful models we already have access to right now.
Yeah, and what's truly fascinating here is that the breakthrough so many are looking for isn't really in raw AI intelligence itself. It's in a concept the source calls context engineering. So this deep dive is all about understanding exactly how to design that whole information ecosystem that feeds an AI. And then crucially, how to integrate that intelligently into your day-to-day workflows. This isn't just, fiddling with prompts slightly. It's presented as a potential path to a 10x career leap. Why? Well, because companies don't just reward solo coders, they reward force multipliers, people who can amplify the output of the entire team. And context engineering is positioned as how you do that, by automating complex cognitive work, cutting down friction significantly, and ultimately owning outcomes that really drive the business forward.
That's a really powerful distinction, a force multiplier. So, for you, our listener, you're about to discover why context engineering is becoming, well, one of the highest leveraged skills an engineer can have right now. We'll dig into the practical techniques that make AI output incredibly fast and, importantly, accurate. We'll see how to apply them to real engineering headaches, like totally transforming code reviews. And crucially, how to turn those results into solid, promotion-ready evidence for your next big career move. It's really about making AI work for you and strategically for your career. Okay, let's start with a really basic question then. Why can't even the best, most advanced large language model just understand your company straight out of the box? These models are undeniably powerful, we all see that, but our source points out they arrive with, well, zero awareness of your specific architecture, or your unique business rules, the team's culture,
Right, they don't know your microservices, your internal coding standards.
or that vital context buried in some Slack thread from 6 months ago.
Exactly. And without all that intricate insider knowledge, the AI's output, no matter how polished it sounds,
hmm
it's going to be generic
Mm.
and often subtly wrong in ways that really, really matter for the business.
Yeah, subtly wrong can be worse than obviously wrong sometimes.
Definitely. And this is where the source uses a really clarifying analogy. Imagine an AI without specific context. It's like a brand new hire, maybe with an incredibly high IQ, but it's their very first day. They might be brilliant, technically sharp, but you,
Yeah.
as an experienced engineer, maybe you've been there 3 years, you're going to outperform them significantly.
Okay, I see where this is going.
Yeah, because you know the unwritten rules, right?
Hmm.
The approval flows nobody documented, the hidden dependencies between services. You remember past incidents, those edge cases that could cause regressions? You know exactly where to find answers quickly, cutting down cycle time.
You know who to ping on Slack.
Exactly. You understand the cross-team dynamics, who needs to be involved and when. The core insight is you create impact, not just by being the smartest person in the room, but because you deeply understand the business domain, the unique environment you operate in.
That analogy really does crystallize it. Raw intelligence isn't enough without the operating context. But I wonder, does focusing so much on context ever limit the AI? Like, does it make it less creative or unable to generalize?
That's a fair question. It's definitely a balance. Context engineering gives you precision, relevance, which is usually what you need. But yeah, you still need the underlying models to be capable, or maybe you chain different specialized AIs together. For, I'd say, 90% of engineering tasks, though, the precision you gain from context, it far outweighs the risk of maybe missing some wild, unexpected connection. And the same logic applies directly to the AI. A model without context is like that brilliant new hire without onboarding. But feed it the same environment you operate in, all that critical insider info, it transforms. It becomes like a high-speed extension of your own brain. And that is the essence of context engineering, giving the AI your insider advantage, leveraging your knowledge.
Okay, so we've established the why. Context is king. But the big question for everyone listening is probably, how do we actually do this?
Yeah.
How do we get from understanding why to the tangible how that drives that 10x impact? The source is clear. This isn't just about like writing slightly better prompts. It's systematic. Let's dive into those core techniques.
Absolutely. The source lays out 9 core techniques,
Right.
and combining them is where the power really comes from. First up, system instructions. You might also hear this called role or persona prompting. And this isn't just telling the AI, act like a senior engineer. The key insight is how deeply this shapes the entire output. It sort of prunes the possibility space up front. It prevents irrelevant or overly generic answers before you even ask the main question.
So it sets the stage, gives it a viewpoint.
Exactly like saying you are a principal software architect explaining event-driven systems to a mid-level engineer. That automatically guides its tone, the level of detail, the perspective. Saves a ton of back and forth.
Right. Sets the frame. Makes sense. What's number 2?
Second, Retrieval Augmented Generation,
Yeah.
or RME. Big buzzword. But the concept is key. This is about combining the model with external knowledge sources, authoritative ones. Think about documents you might put in a vector database.
Okay. Vector databases store data based on meaning, right? Not just keywords.
Precisely. Crucial for AI. Or even just a standard PostgreSQL database with the PG vector extension installed lets your normal database do vector searches. So instead of just relying on what the model was trained on ages ago, you retrieve relevant, current documents, your documents, and feed them into the prompt right now. This ensures the answers are accurate, up to date, and grounded in your specific, maybe proprietary data.
That's huge. So is the main challenge there just getting all your docs into the vector DB, or is it more about crafting the perfect search query?
Both are important.
Yeah.
Getting the data in is step 1, obviously, foundational. But then optimizing retrieval, that's an ongoing thing. Okay, next up, short and long-term memory patterns. Short-term is basically what the AI remembers within the current chat window, everything you just said, the immediate context.
Like it's working memory for this conversation.
Exactly. Long-term memory is more persistent. Think like ChatGPT's custom instructions or memory feature. It stores facts, preferences, your working style across sessions. So the AI builds up a deeper understanding of you and your needs over time. It's like building a user profile.
Got it. Immediate versus persistent knowledge about me or the project.
Perfect. Fourth technique, web search grounding. This lets the AI enhance its answers with real-time search results. You basically tell the model, go look this up, find the latest info, and base your answer on that.
Oh, that's useful. Like, summarize the latest changes to React hooks, but only use sources from the last 6 months.
Precisely that kind of thing. Keeps answers fresh, especially in fast-moving tech.
Okay, super practical. What about the prompts themselves? You said it's more than just tweaking.
Right. Fifth is a big category. Prompting itself, covering a whole range of techniques for fine-grained control. There's constraint-based and negative prompting, specifying what it must do and, just as importantly, what it must avoid.
Like, don't suggest solutions using framework X.
Exactly. Saves you filtering out bad suggestions later. Then there's prompt layering and lazy prompting, breaking complex tasks into steps. Give the first instruction, wait for the output, then give the next layer, like a guided conversation.
Instead of one giant, overwhelming prompt.
Right. And related is prompt pipelines and chaining, feeding the output of one AI call directly into the input of the next for multi-step workflows. We also have zero-shot prompting. Just give the task, no examples, relies on the model's base knowledge. And the opposite, few-shot prompting. Include a few examples of the input and desired output to guide its style and accuracy. Very powerful for specific formats.
Wow, okay. That's a lot just within prompting. It really is a craft. Do you find engineers tend to overlook any of those specific techniques?
Good question. I think negative prompting is often underused. People focus on what they want, but forget to explicitly rule out what they don't want. It can save a lot of hassle. Okay, moving on. Sixth, MCP tools. Stands for Model Called Programs, or sometimes multimodal chain of thought tools. Basically, external tools the AI can use, APIs, plugins, calculators.
So the AI can do things it wasn't originally built for, like math or accessing private data.
Exactly. Things that are inefficient or impossible for the language model alone, like calling an internal company API to check inventory. Seventh, guiding the model's reasoning. We don't just ask for the answer, we ask it how to think. Chain of thought is getting it to think step by step, linearly, show its work.
Helps you see its logic.
Right. Tree of thought is more advanced. It explores multiple reasoning paths or possibilities before concluding, like weighing pros and cons. And decomposition, breaking a big, complex problem down into smaller, manageable parts for the AI to tackle one by one. Super useful for large or ambiguous tasks.
So you're essentially asking for the roadmap, not just the destination. That sounds incredibly useful for debugging or refining the output.
It really is. Okay, eighth technique, workflow orchestration. This is about coordinating multiple AI agents or tools in a sequence. Each agent does its specific task, then passes the results to the next one. This might use protocols like A2A from Google or ACP from IBM, basically, standardized ways for AI components to talk and coordinate.
Building complex, multi-stage automations.
Exactly. Think. AI analyzes a bug report, then generates test cases, then suggests code fixes, whole pipeline. And finally, number 9. Input-output context. Sounds simple, but it's crucial. Clearly defining the structure of your input and critically the format you expect for the output, like the source example. Input is JSON with fields X and Y. Output a markdown table summarizing key values with columns A and B.
So no ambiguity. Tell it exactly what form the data comes in and goes out.
Precisely. Makes the output predictable and much easier to plug into other scripts or systems.
Okay, that's a comprehensive toolkit, 9 distinct techniques. It really emphasizes that layered approach, and I think the source is spot on. The real magic happens when you start combining these. But theory is one thing. Can we walk through a concrete example? How would an engineer actually use these techniques for something like code reviews? Everyone does code reviews.
Absolutely. Code reviews are a perfect candidate for this kind of transformation. The source paints a picture of the old way, which, well, it probably sounds familiar to a lot of listeners. Manually juggling multiple PR files, clicking back to the JRA ticket, trying to find the design docs somewhere.
Relying on your memory for the team's coding standards.
Right, and then spending, what, 45 minutes carefully writing out comments, maybe longer?
Easily. It's a huge cognitive load, constantly switching context in your head.
Exactly. Every step depends on your ability to juggle all that mental context. It's draining.
And honestly, a lot of the comments end up being kind of repetitive, nitpicks about style or things the linter missed.
Precisely. But with context engineering, even a basic MVP, a minimum viable product, can radically change this. First step, context aggregation. This could start super simple. Maybe a little grease monkey script that copies all the PR file contents to your clipboard in one go. You grab the ticket description too, maybe link to the design doc if it's handy. The source calls this a manual RAG step because, okay, maybe your docs aren't in a vector DB yet, but it takes like under 2 minutes.
So just gathering the relevant info up front, even manually.
Yes. Step 2, load your prompt library. This acts like your long-term memory for code reviews. It's a pre-written, really rich prompt that holds all the essential context the AI needs for this specific task.
Okay, what goes into that rich prompt?
This is where you combine several techniques. Rich prompting. You give the AI a clear role, like you are a staff engineer reviewing this code. You paste in the team's actual coding standards. You define the expected output format, say a markdown table with columns for file, line number, issue, and suggested fix. You include reasoning instructions. Focus on logic, maintainability, and adherence to standards. You might even include a few shot examples of good comments written in your team's specific style.
So it learns the tone and substance you expect.
Exactly. You can embed the coding standards right in line for easy reference. You could even add a command for it to check external libraries mentioned in the code against public vulnerability databases using web search grounding.
Wow. So you're basically giving the AI a complete mental model of what a good code review looks like for your specific team.
You got it. Then the AI generates its review, probably that nice markdown table format you requested. And here's the crucial part. Human in the loop. The human that's you becomes the final filter. You quickly scan the AI's suggestions. Discard the low-value comments, the nitpicks maybe. Keep the high-value ones, the ones that correctly identified issues against your standards. And then you add your own unique insights, the architectural concerns, the subtle design trade-offs, the stuff only your experience can spot.
So the AI handles the routine stuff, freeing you up for higher-level thinking.
Exactly. The outcome. The review is faster. It's way more consistent across the team because everyone's using the same base standards via the prompt, and it creates this reusable paper trail of feedback. The core benefit is clear. AI handles the comment grunt work, freeing up the human engineer to focus on what truly matters.
That's a massive shift. From context juggler to critical thinking filter. Much better use of an engineer's time. Now, this all sounds fantastic for productivity, but let's be real about careers for a second. Managers don't usually promote you just because you used AI, right? They care about measurable impact. So how do we translate these context engineering wins into that solid evidence needed for a promotion, for that next career leap?
Absolute critical point. You have to translate the effort into proof, tangible, quantifiable proof. Managers are looking for things like higher velocity, lower risk, fewer cross-team blockers. Measurable stuff. So first, collect before and after metrics. Seriously, measure it. Document the time saved on code reviews, maybe track a reduction in bugs found later, or the increased speed of deploying features touched by this process.
Get the data.
Get the data. Second, keep meticulous artifacts, links to your prompt library. Short demo videos showing your scripts in action. Entries in a decision log showing concrete minutes or hours saved per task. Create that evidence trail. Then, when it's promotion time, our source suggests framing it like a case study.
Okay, like problem, solution, results.
Exactly. Problem statement. Code reviews were slow and inconsistent. Approach. Developed a context engineering pipeline using techniques XYZ. Measurable result. Reduced average review time by 30%. Increased detection of standard violations. Include sample artifacts. And crucially, get stakeholder endorsements. Quotes from team members or your manager saying how it helped them.
That makes sense. Build a compelling story backed by data and proof.
But don't stop there. The real key to becoming that force multiplier is to scale your influence. Don't just hoard your awesome prompt library. Publish your context vault internally where others can find it. Run a quick 1-hour workshop showing your team how to use your tools or techniques.
Teach others how to fish.
Precisely. Create reusable templates based on your prompts. Pair with a couple of other engineers. Help them adapt your playbook to their specific annoying tasks. And then, record their results too. Add those wins, the impact you had on others, to your own promotion packet. The more you're seen as the person improving how others work, the one making the whole team more effective, the stronger your case for promotion becomes. You're demonstrating high-leverage impact.
That is an excellent blueprint. It's not just about doing the cool AI stuff. It's about proving the value, scaling it, and making it about the team's success too. Okay, so to wrap things up, let's give our listeners a clear, actionable challenge straight from the source material. This week, right now, pick one task. Something boring, repetitive, maybe ambiguous that you deal with regularly. Design a context pipeline for it. Doesn't have to be perfect. Use some of the techniques we talked about. Ship a minimum viable automation for that task, even if it's just a slightly better prompt or a small script. Then measure the minutes you save. Just estimate it if you have to. Add that to your decision log or just a note somewhere. And then, this is key, bring those results to your next 1.1 with your manager. Remember the advice. Ship the automation, show the delta, the improvement, and ask for more responsibility in your next performance review. That's your direct path.
And maybe one final thought to chew on, something beyond the immediate task. This whole discussion raises an important question, doesn't it? How much of this context engineering do we already do, just as humans, without thinking about it? We spend years building our own internal knowledge graphs, right? Understanding dependencies, learning the team's history, the company culture. How can we consciously apply these same principles, providing the right information in the right structure at the right time to improve our own human productivity and problem solving, even without involving AI directly? Because ultimately, it's not just about the intelligence of the AI model itself. It's about the intelligence of the entire system we build around it. And maybe the system we build around ourselves. It's about deliberately creating an environment for humans and machines that's rich with the context needed for truly effective, impactful work.